Hello everyone, my name is Beres and today's presentation is titled The Effects of Climate Warming on Freshwater Fish Species. Climate change is one of the main threats to aquatic ecosystems and freshwater biodiversity, and therefore has become a hot topic in fisheries biology worldwide. This presentation is aimed to broadly outline some climate effects on freshwater species only. First, I will go over some of the climate-related threats faced by freshwater species, highlighted by a few examples from previous research to help you gain a better understanding of the topic. We will look at the effects of these threats as noted by a few different studies. Next, I will discuss a more specific area in this topic that I would like to research in the future, regarding distribution changes of Connecticut freshwater fish, such as the cute little brook trout you see here. I'll also introduce a few labs and organizations in the state where research is currently taking place. And finally, as with any research, there is potential for obstacles, so I'll do my best to address a few of those. Climate shifts over the past few decades have contributed to rapid changes in freshwater ecosystems around the world and will continue to do so in the future. So let's take a look at a few of the more prominent threats regarding freshwater fishes. Increased water and air temperatures are the more obvious direct effects of climate change, and with good reason because they're some of the most powerful. The graph on the right here shows changes in two Oregon and Montana stream temperatures just over the past few decades. Some fish are particularly susceptible to changing temperatures, which we'll discuss in a bit. As exotherms, freshwater fish cannot regulate their body temperatures, and often do so behaviorally, which is inherently subject to environmental constraints. Therefore, increased temperatures affect physiological functions such as thermal tolerance, growth, metabolism, consumption, reproduction, and maintaining internal homeostasis in a variable environment. While many factors affect dissolved oxygen levels in water, oxygen solubility has an inverse relationship with water temperatures. So as temperature increases, dissolved oxygen decreases. But that doesn't mean cold water can't be depleted. The formation of dead zones are not the only problem in freshwater. Fish species that occupy the thermocline and hypolimnion as thermal refuges in stratified lentic habitats can be strained by longer periods of summer stratification. Warmer epilimnion waters and overused hypolimnion zones increase and force more fish into a smaller thermocline habitat. Drought and fish kills are not uncommon phenomena in freshwater systems, but extreme cases have altered fish assemblages and slowed subsequent recoveries in the past. While the exact mechanisms of how droughts affect fish have not been extensively studied, increased and more severe instances of drought may end up having a very lasting impact on some populations. Warming temperatures compound a seemingly endless web of other issues for both cold and warm freshwater fish, and the impact of each becomes greater as more challenges surface and combine. It can allow for invasive species to become more easily established. Fish are more likely to be harmed by pollutants. Eutrophication may be more common in lakes and ponds with increased light and nutrient availability. Fish become more susceptible to disease and parasites. Food webs are disrupted. Competition is increased. Depleted fisheries are further strained. The list goes on and on and on. So what effects can we actually see now? Changes in species abundances have and will continue to result from changing air and water temperatures. This 2013 study by Comte and Grenoillet examined distributional changes in 32 species of freshwater fish as an attempt to see if stream fish track climate changes. This offers a good example of how species abundances have changed as well. For example, see Lipomus gibosus, which is a pumpkin seed, with an initial detectability of 0.46 at some point between 1980 and 1992, and now has a contemporary detectability of 0.68. The time period included a slight increase in average temperatures for the area. Pumpkin seeds typically inhabit warmer lakes and stream pools, and you've probably seen these and other sunfish on nearly any lake shore in Connecticut. Warmer water creates more space for these less picky species and more opportunities to capitalize. Like abundances, fish distribution has been and will continue to be similarly affected with changing temperatures. Cold water species like salmonids can be reduced to higher altitudes or latitudes, whereas cool and warm water species like the sunfish we saw can expand or contract their ranges. This is from the same 2013 study, and this graph highlights changes in distributions over time. White bars represent the overlap of the initial and contemporary distributions. Gray bars represent range expansions and altitudinal shifts in the top graph. And black bars represent contractions. So you can notice the vast differences over time in the silver bream here, the burbot, and this Atlantic salmon. These anadromous salmonids were actually once abundant in Connecticut, but they've severely declined over the past few decades. And if you look from this graph, you can see that the gray bar indicates a shift in elevation, and they're probably chasing colder waters. So as you can tell by now, temperature plays a huge role in fish species abundance and distribution. The complicated issues that arise require thoughtful and novel solutions from fisheries management agencies, and the University of Wisconsin-Madison's Crystal Lake Mixing Project has been doing just that. Rainbow smelt are an invasive species in the Great Lakes and nearby Crystal Lake in Wisconsin. Smelt are voracious predators. I know they don't look like it, but they've displaced a lot of native species such as walleye and yellow perch because of competition for food resources. The smelt occupy different thermal habitats with specific temperature ranges over their life history, from the warmer Epilimniana's younger of year to cooler waters near the bottom as they mature. So check out the increases of smelt catches compared to the decline of perch catches over this 25-year period. It's pretty drastic. Climate-induced changes and the resulting increases in summer stratification periods may have served to only compound this problem. Rather than poison or bubble the lake, this project moved huge, trampoline-like objects through the water column in an attempt to mix the thermal profile and drive smelt out of their preferred habitat. As far as I can find, the final outcome of this project is yet to be announced, but one local source reported in 2014 that invasive smelt mortality increased from the normal 40% to 90% per year. These novel solutions will be required for many of the temperature-related threats we've talked about today, and coming up with solutions will require continued research. If I were able to choose any fisheries-related or climate change-related project to work on here in Connecticut, personally I'd like to examine the shifts of Connecticut's wild trout populations, both native brook trout and the brown trout you see in this video. These were stocked as fry, but they matured in the stream. Trout are extremely vulnerable to changing water temperatures. Browns start experiencing temperature-related stress at around 20 degrees Celsius, and brook trout experience stress a few degrees lower. Connecticut Deep and volunteers go to great lengths to sample and protect the state's trout. Every summer, Deep and volunteers create angling band thermal refuges where cold water streams such as Furnace Brook flow into the rapidly heating Housatonic River. In the hottest days of summer, there could be hundreds of fish in this one refuge. Additionally, Deep has sampled Connecticut's waterways to assess the distribution and abundances of the state's trout, resulting in a large database of previous year sampling. I think trout range comparisons over time and compared to climate changes would make for a useful, rewarding, and very fun project. And now I just need to know where to go. For obvious reasons, Deep Inland Fisheries Division would be my first stop. It's split into a western and eastern district, and the department has offices in Litchfield, Harwinton, and Marlborough. Along with the state's trout sampling efforts, the department collaborates with other organizations on plenty of worthwhile fisheries research projects. The NOAA Northeast Fisheries Center is based out of Milford, Connecticut. Research is currently underway there to characterize Atlantic salmon habitat. The species has been in decline for decades due to water quality issues, hindered migrations, and overfishing, as well as other problems that could be compounded by climate changes. The U.S. Fish and Wildlife Service Connecticut River Coordinator's Office is located in Sunderland, Massachusetts. This organization works to balance the needs of aquatic animals with the ever-changing state of the surrounding environment. Some of their research includes Atlantic salmon work. They do daily fish counts at fish passageways, as well as fish passage projects, invasive species research, and contaminants assessments. Now, aside from government agencies, conservation groups offer endless potential for research opportunity. Trout Unlimited is more than just an angling interest group. TU is a conservation organization dedicated to freshwater resources, and it's divided into 8 chapters throughout Connecticut. The organization funds ongoing research projects aimed to protect trout species, reconnect fragmented habitat, restore degraded habitat, and sustain interest in species through public education. TU's ideology is perfectly demonstrated by their motto: if you take care of the fishing will take care of itself. Finally, the Yukon College of Health, Agriculture, and Natural Resources is located in Storrs, Connecticut. The Fisheries Management Program offers applied research in fisheries management and ecology focused on the state's resources. The department is concerned with a number of research topics such as lodic and lentic fisheries assessments, population dynamics, habitat, contaminants in fishes, and species of special concern such as brook trout. The National Science Foundation is constantly awarding grants for graduate research. I was able to find several openings for graduate research fellowships, which would be applicable for a wide variety of topics. But even better were the long-term research funding opportunities. These are geared towards projects that address population dynamics, ecological processes, or other topics that could not be addressed with short-term observations or experiments, mainly everything we've discussed in this presentation. The contact info for the LTER funding opportunities and a link is posted on this slide and in the notes. Of course, there are a few potential obstacles regarding any fish distribution or abundance survey with regards to climate changes. There's been a ton of previous research on climate change over the past few decades, but with the rapid pace of warming waters further stressing fragmented and depressed habitats, there still is much that needs to be learned in a relatively short period of time, especially on changing lodic thermal regimes and consequent ecological responses. How do we know if action will be effective, and how do we measure that? Working with organizations does come with a large amount of responsibility. There needs to be results. While a lot of grant money is available for habitat research and remediation, projects can get very expensive very quickly. Additionally, in an uncertain, warmer future, any past or current successes may again become vulnerable to persistent rising temperatures, especially if the habitat has become shifted away from the target species. It's difficult and disheartening, but sometimes you have to ask whether it's really worth it. In the same regard, do enough people or organizations care enough to preserve river and stream biodiversity and support these projects? From my experience, ecology projects tend to take a back burner to many other biological fields on a nationwide scale, especially when it comes to trying to find employment or research opportunities. However, I think the answer is certainly yes. Whether you're a naturalist, an angler, or just someone who likes having picnics by the water, the natural beauty and free services of healthy habitats and biodiversity absolutely warrant further research and preservation. I think a great way to get more people involved and interested is through public education, citizen science, and youth educational programs, which a lot of organizations do now. If you instill students with a respect, interest, and passion for fisheries and the outdoors overall, it's really the best way to ensure sustained progress as in an uncertain future. Thank you for watching. I hope you enjoyed my presentation today. Please feel free to contact me at the email below with any questions or comments.